Hello everyone, my name is Pawan Podila, and in this session I'm going to talk to you about state management in Dart and Flutter apps using the Mobx framework. Now, state management is actually a pretty hard problem, and we can see that as your application grows in size, the amount of data that you're going to manage and the amount of interactions and the interdependencies that you have between various features can become a little tricky to deal with. So what I want to focus on in this session is to show you that in a Mobx can help you simplify that kind of state management and look at its abstractions and also some examples in code so that you can see for yourself how it takes away the pain of managing state and lets you focus more on your own application and business logic. So let's get started with state management in Mobx. Now, as I stated earlier, state management is actually a hard problem. Now, when you have a very simple application, which has just one feature, maybe it might be easy to manage the state that you have in your application. And by state, I mean any data that is used across the application to render the different parts of your UI, right? So initially, the state looks very simple and it's easy to manage, and you can probably get by simply using the set state inside Flutter. And as it gets more and more complex, you can probably start adding more management features like providers and a specific framework like Mobx to manage the state. But initially, of course, everything looks simple and it's clear. But as your scale of your application increases, this can be a tough problem to deal with. Now, one thing to remember is that the relationship between data and UI is actually critical in this application. And although the designers in our application team could be creating something really fancy and make it seem like the UI is the most important aspect, what really is important to understand over here is that data is the heart of your application, and it is the data that drives the UI. Ultimately, if you think of it, it is the pixels on your screen are ultimately painted versions of your data, right? It's the visual counterparts of what you have in your data and object models. So it's the data that is very important, and it's you should be spending more time making sure the object modeling and the way the relationships between various entities inside our application are structured and modeled, and give careful thought to that before you jump on to making it look beautiful on the screen. And of course, Flutter can help us in making things look beautiful. But before we get there, you should always take a step back and realize that data is the most important aspect and the critical aspect of building applications. Now, we are talking about state management, right? So let's start with something very simple and the basic. Now, state is something that is read synchronously by the UI. And I'm actually highlighting the parts which are very important in this particular statement. So state is something that is read synchronously by the UI, but when it is rendered, it is notified to the UI for scheduling an update, right? So as soon as the state is read inside a build function of your widget or in some other parts of your UI, the data may be read synchronously, but the painting of the data on the screen happens asynchronously. Right? It doesn't happen immediately as soon as the data is read. It in fact happens by a scheduled update, which is pushed onto some kind of a queue, which eventually gets flushed out to the screen. Right? So it's very important to understand this duality over here. The state is, although read synchronously, is pushed out to the screen asynchronously. Now inside your application, the one which is the state or the screens which are visible to you carry very little state. And that state is only a small part or a subset of something much larger called the application state. And this application state resembles the submerged part of an iceberg. Right? What you see on the screen is after all, a very small part of the application state. And as you move between different screens, you'll probably be seeing different parts of the application state. But the thing to remember here is that every screen full of data that you're showing on the screen is only a small part of something much bigger. Now, before we go on to understand how Mobx tackles state management, let's build some mental model around how state in general changes over time. Now, and this is called as the side effect model. Now, the state sits at the center of everything. And in order to mutate or change the state, you need to apply some actions. Now, you could actually change the state directly, but that is not a recommended approach. What you want to do is do it through a specific abstraction called an action. And we need this abstraction called the action because it gives a semantic meaning to the specific mutation that you are applying to the state, right? So by applying these actions, you can mutate the state. Now, just by mutating the state is not going to make things interesting. What you need ultimately are also to visualize these changes on the screen, and that's where you need the observers. So that's the step 2 of your entire side effect model. The step 2 is where you need to apply some observers, which are going to listen to these changes in the state and then do side effects or mutations, or not side effects, but sorry, not mutations, but updates to the screen, which are shown in the form of UI changes, or it could be some animations, or it could be some network operations, and so on. So at the center of it, you have the state, actions mutate the state, and then you have observers, which will look at these changes and then do some side effects over here. Now, one thing to note here is that the side effects are separate from the actual mutation, right? The observer is the one which instigates, or rather invokes the side effects, and this is happening after an action is applied. Now, these side effects can also obviously fire more actions, and that completes the loop which you see over here. So that is how a state inside an application constantly keeps on changing. Now, these changes could be happening through specific actions fired by the system, fired by the user, or also some automatic actions happening in the background. And that completes the loop of your side effect model. So at the heart of it, you have the state. And specifically to manage the state as it grows complex over time, we have frameworks like Mobx. Now there are other frameworks as well inside Flutter to manage the state, but here we're going to talk specifically about Mobx and how it manages state inside your application. Now Mobx consists of three important abstractions. You have the observables, which carry the reactive state of your application. And by reactive, I mean anytime you make modifications to the state, it fires a notification. And this notification goes out to all the reactions which are listening to the changes in the state. So that's the second abstraction we have in Mobx, which is reactions. So observables fire notifications when changed, which are notified to the reactions. Now these reactions can obviously also fire more actions, which are semantic operations applied to mutate the observables inside our application. Actions have semantic meaning, so instead of simply saying value plus plus, you have a semantically named operation like increment count, right? Which of course sounds more meaningful than simply saying value plus plus. Now, these are the actions which will mutate the observables or the reactive state of your application. And these three pillars are the triad of abstractions inside Mobx, happen in a unidirectional format. The flow of information over here is always unidirectional. So the reactions fire actions, actions will mutate observables, observables notify the reactions, and that's how the loop or the circle of life happens inside Mobx. Now let's look at specifically the kinds of observables that Mobx provides. Now what an observable does, and one of the core behaviors of an observable, is to notify its own changes, right? So here we have a change being applied to an observable, and when that change gets applied, all the notifications are fired out to anyone who's listening to that particular observable. These observables obviously come in various shapes and sizes. You can have a single unit observable, which is simply like a number or a string or a date or something singular. You can also have a list of items that gets monitored over time, and you can add and remove items and see the visualization on the screen. You can also have a dictionary or a map, a set of items, future, and stream. And as you can tell from the names given to these different kinds of observables, they cover pretty much every single data structure that Dart provides to you as a developer, right? So you can start with the plain primitive values, you can have lists, maps, sets, future, and stream. And all of these have a prefix to them in Mobx, which is an observable, right? So you have an observable list, observable map, set, future, and stream, and so on. And the only additional behavior that these observable counterparts add to these data structures is that whenever a change happens, they notify it to the outside world. Now, an additional observable that you find inside Mobx is called as computed. And computed, although is underrated, is probably the most important way in which you can manage more complex state inside your application. Now, what computed observables really do is that they don't really carry any inherent value of their own. They instead depend on other observables to derive their value, and that's why it's called computed or derived. So it's actually quite important to think of your state in the form of computed observables wherever possible. And that's what you'll see in this next slide over here, which is the entire state of your application, the reactive state of your application, can be broken down into the core state and the derived state. Now the core state is something which is inherent to your application. Now these are properties which are actually part of your domain. So as an example, if you have a contact book application, let's say, the contact is something which is inherent to your domain itself, right? The first name and the last name are state values which are inherent to the domain. Whereas a full name is not something inherent to the domain. It can be derived from the combination of first name and last name. You can do different juxtapositions of these two values, right? You can either have first name before, followed by last name, or last name first with a comma and then a first name. All that is derived information from the core information, which is first name and last name. So that's all about the core state and derived state. If you think of your application in these two formats, you will see that a lot of the complexity inside your application can be pretty easily managed by breaking it down into the core and the derived. Now, the next thing to do and worry about after you have defined and modeled your reactive state is to think of the actions or the operations that will be performed on your domain to make these mutations on the observable state. Right? And these operations could be given specific names like update the contact, change value, increment value, add value, and so on and so forth, right? These are specific names given to the actions inside your application so that you know what changes you're making to the observable state. Now, of course, as I said before, actions on their own are kind of meaningless. And even though you're making mutations to the observable state, unless someone is actually observing things, the system itself is kind of meaningless and boring. So there are also observers which are going to listen to these notifications. They're going to come out of the actions. Now, the actions can actually be nested to create more complex actions. And the thing to note over here is that although you can have several actions being nested inside, the notifications will only go out when the topmost action completes. This actually is a performance benefit that you get out of Mobx, so that there is no noisy changes and noisy notifications being sent out prematurely. Right? Otherwise, you would be looking at things even before the whole thing has completed. So actions ensure that they are part of a transaction boundary and they only fire the notifications as soon as the topmost action completes and not before. And finally, the third pillar of the Mobx triad is your reactions, which also come in various forms. And reactions are the one which are going to be the observers of your system. So you have observables that are mutating and firing notifications whenever they change. Actions are the semantically named operations that make those mutations. And then on the last third side, you have the reactions, which are going to observe these changes and perform various kinds of side effects. So you have various kinds of reactions, which is auto run, when, async when, reaction, and of course the observer. Now, as you build your Flutter widgets, the observer widget is something you'll be using very frequently inside your application. And we'll get to that once we look at the code. So just to summarize, what we get in Mobx is a triad of abstractions, the observables, actions, and reactions, which all flow the information in a unidirectional form. And that is how the reactive system inside Mobx works. So now that we understand how the basic system of Mobx works, let's take a step back and just look at the project itself, right? Now, Mobx itself is an inspiration from the Mobx framework from JavaScript. And I was a contributor to there before coming to Flutter. And I saw that in Flutter, having Mobx as a framework would be definitely beneficial. So I started working on that in somewhere around December 2018. And I launched it publicly in Jan of 2019. And since then, it has gained enough amount of traction, and a lot of people were using it now. And we have crossed even 1,000 stars in the beginning of the year. So we are close to 40 contributors. And Mobx itself is actually broken down into 3 sub-projects, which is Mobx the core. You have a code gen, which makes it easier to kind of handle all the boilerplate so that your code as a developer doesn't get cluttered with all kinds of Mobx related things. So we have a code gen, which kind of puts things in the background, and you only include a part file inside your main Dart code, and just the whole state of your application looks much more clean. And then you have the Flutter bindings, which comes in the form of the Flutter Mobx project. So that's Mobx in a nutshell. And now I think with that kind of a background, let's take a look at the code which drives Mobx, and you can see for yourself how Mobx as a framework can simplify the various scenarios that you handle inside your application. All right, before we jump into the code for the examples, let's take a look at the examples itself. Now we're going to look at first the simplest one, which is the counter example. And this is a classic one which you will learn when you're learning Flutter for the first time. So you press a button and the count keeps on incrementing. Right, so this is a very simple one. Now let's take a look at the code for this. So if you go into the Mobx project and git clone that, you'll get all of these projects in one monorepo. And if you go to the Mobx examples code folder, you will see under lib counter the specific file for this particular example. Now, what I've done in addition to writing the store class, which is the main central class for Mobx, there's also a store counter.g.dart. And this is a file that gets generated when you run a command in the background. So there is a build run a command that you run, and you can learn all about this when you go to the Mobx website, and I'll show that to you a little later. There's a getting started guide which will give you all the information about how to get started with Mobx and all the commands you need to run generate the boilerplate files and all that. So for here, let's just focus on the counter example. And here you can see that the example by itself is pretty straightforward. You have a single reactive value, which is the value itself, which is marked as an observable, and you have an action that increments it. Now note that we could have done value plus plus straight away, but instead of doing that, we have kind of wrapped it inside an action, naming it as increment. And this makes it easier for us to know that what kind of operation we're performing on the reactive value. So that's all about the store itself. And don't worry too much about the little boilerplate you're seeing over here, which is the part statement and then the class counter and the abstract class. This is the same boilerplate you'll be applying to pretty much every single Mobx class that you'll be creating. All right, so what we've done over here is created a store and added a reactive value and a reactive and an action that mutates the reactive value. Now, in terms of the visualizing the update itself, you'll see that the counter widgets contains the observer, which is observing the counter value, right? And the fact that the counter value is being observed over here is a hint for Mobx to know that whenever this particular value changes, this particular widget needs to re-render itself. And that's exactly what happens over here, right? When you press the button, and you'll see over here that pressing the button happens in the floating action button, where on pressed is actually calling the action increment. So when that happens, the value changes, and since the observer is tracking the changes to this value, it re-renders itself and shows the new value. So that's how the Mobx flow works, right? So you have an observer, observable, an action, and a reaction, which is the observer itself. The triad is kind of working together over here. All right, so that's how the basic counter example works. Now, in addition to being a simple example, you can also notice a few things which are consistent across Mobx code bases, irrespective whether it's small or big. Now, nowhere have you seen any subscription or any kind of notification handling or attachment of extra event handlers and so on and so forth over here, right? The things were pretty automatic. All you did was to express your intent in terms of creating an observer and observing a specific value. And that's good enough for Mobx to start tracking this particular value and making sure that the observer re-renders anytime the particular value changes. All right, for the next example, let's look at the to-dos. Now, to-dos is like your classic holy grail of state management frameworks. Almost every framework out there, at least in the JavaScript world, has an example in to-do, and to-do MVC rather. Now, this is just a way of passing and showing that another framework actually works and is able to handle a complex scenario or set of scenarios that are present in the to-dos. So let's see this example in action first. All right, so the first thing is that I can obviously add a new to-do. So let's say record or give a talk. Okay, and then I'll say gather feedback, and what else can we do? Maybe complete the dishes, right? Obviously we are all in the COVID time, so that's one of the activities we all have at the end of the day or beginning of the day. So let's just take care of that too. All right, so I have these 3 tasks now, and I can obviously switch between all tasks, the pending tasks and the completed. So let's just mark a few of them as completed, and I'm going to just take the liberty and say that I am done with dishes for today. So if I go into completed, you will see that particular task showing up over here, and you still have 2 more pending tasks. Also, the description for the two tasks have changed, right? You have two pending to-dos and one completed. And if you go to all, you'll see this. Now, if I mark one more as completed, notice the description has changed, and also, when you switch between different filters, you will see those talks showing up over there. Now, one thing interesting over here is that notice the enabled and disabled state of these buttons, right? When you go to completed, now obviously since all of them are already completed, you can't mark them as completed anymore. And the same goes when you go to all and you check all of them, right? You can't see that, you can't do the mark all completed anymore because you already have all of them as completed, right? Now also in pending, you will see that since none of them have been completed, this remove completed button has also been disabled. And that's happening because when you go to pending, the list that you see over here does not contain any completed tasks. Right, so there is a change in the status of these buttons, the enable disable state of the buttons. The description is changing, and also, of course, when you click on and check and uncheck the tasks, things are changing. And you can also, of course, delete some tasks like this. In which case, the counts update, the description updates, and so on and so forth. So just in a very simple example like to-dos, you will see that a lot of interactions are present, and different aspects of the UI needs to be updated based on a consistent data model. Now, this might look a little complex when you just look at it as an example, but let's start seeing it in code and see if there is enough complexity in the code as well. And I'm kind of giving away the fact over here that the complexity is kind of more manageable when you go to code. So let's just quickly see it over here. So in to-dos, let's start with the data model. In fact, in the presentation, we have seen that the data drives the UI, right? So it's all about data modeling first, which then results in creating a UI which kind of naturally maps to the various elements of your data structures. So let's just go and see the to-do.dart. Now this is just a simple class that that contains, it's a store, it's a Mobx store, and that contains a single observable value. So rather a observable value which is description. That's the title that you see over here in the simulator, and also the done flag marking whether the task is completed or not. Right, that's just a single to-do that you're dealing with. And then you have the to-do list, which contains the list of all the to-dos that you see here. Now the to-do list itself contains pretty much the only observable value that you see over here are the to-dos and the filters that you're changing and the description that you're tracking from the user, right? So these are all the observable values that keep changing. And the way to think about the observable values in general of any data model is that these are the values which are constantly changing. They could be changed either by the user, or it could be a system managed change, or it could be any observable value that has some equivalent on the UI, either directly or indirectly. Okay, so that's the status, that's the reason why we have these observable values. So filter, the to-dos, and the description. Now that's pretty much the core state of your application, right? Or rather the example. Now if you go back to the slides, you'll remember that we had this description of the state of the application divided into either the core state or the derived state or the computed state, right? And in Mobx, you track this using the observables, which is the core state of your application, and the computed, which is the derived state of your application. And most of the time, the derived state is something that you don't persist, but can be automatically derived or computed based on the core state. So in this to-dos example, outside of the to-dos, everything else is now computed. So let's see how that happens. A pending to-dos is a list which is basically a filter on the to-dos where the done flag is false, right? And the same goes for completed, where the done flag is set to true. And then we also have these has completed to-dos and has pending to-dos, which are computed properties, which depend on other computed properties, like has completed to-dos, which is over here, depends on completed to-dos, which is also a computed property. So in general, when you create a large application in Mobx, you can have this nested computed values, which could depend on other computed values. In general, creating a hierarchy of values, which could be computed from one another, right? So this too is computed. The item's description, of course, is also computed because given the to-dos, we can tell based on the pending versus completed how many are done and how many are still pending, and then generate a string out of it, right? And notice that all of the logic for computing the values is stored in one place. It's not like you're spreading it about in 10 different places, right? You don't have a separate file to manage just the computed properties or the descriptions and so on and so forth. So they're all staying in one place. So the store in as a unit is easier to understand and follow. And if someone joins your team or if it's new to the code base, they should be able to simply go through the data model or just the store class and get a sense of what the application is doing and how the code is managed and maintained, right? So then we have the visible to-dos. This is the list that you're seeing over here, and the visible to-dos actually depends on what filter you have selected, right? So this too happens to be a computed value. The visible to-dos can be computed from the fact that you are looking at a specific filter, and so the to-dos have to be filtered based on that. And that's exactly what we're doing over here. And finally, we have this can remove all completed and can mark all completed. These are two flags which we are kind of computing right inside the store instead of doing it in the widget. Now, the places where these two values are actually used is in these two buttons, the enable disable state of the buttons. And we'll get to that in just a second where we see the widget code. But instead of putting that code inside the widget, which is also a natural place where you can put it, right? After all, it's just a simple check, a conditional check, right? Which you can put over there. But the reason why I want to enforce, or rather recommend people to put these kind of conditional checks inside your store is because that way all the business logic is centralized and kept in one place. And the widget code is simply a reader of these values rather than in being intelligent enough to compute them on its own, right? And also, not to forget, testing becomes easier because now you can specifically test for these values. All right. So in addition to that, all the computed state and the observable state, you also have your actions. And actions are things like adding a to-do, removing a to-do, and removing all the completed and marking all as completed, which is fairly self-descriptive over here, right? So you can see that the to-dos class is fairly well maintained and managed. And although it looks very complex on the screen in terms of the interactions, the data model is kind of consistently doing things and not making it too hard for you in terms of managing it. So that's about the store. Now let's see the widgets itself. Now, the way normally you would structure a large UI is to kind of break it down into smaller pieces and then kind of assemble it together. And that's exactly what we've done over here too. We have the app bar, and then we have all the children, which is starting it as a column. You have the adding of to-dos, the filters, and of course the list of values, the description and the list of values. Now, notice that we don't have one big observer around the entire thing. And that is not really a good way of doing things because, first of all, it becomes too big to manage everything in one place. And we all know in computer science that divide and conquer is the way to go when you have a large problem to deal with, right? So here we're kind of breaking it down or dividing it into smaller widgets and then assigning observers specifically to the parts which need to be monitored and re-rendered whenever they change, right? So if you look at the description widget, it has its own little observer that is only looking at the item description. It's a computer property which is also observable and changes over time, right? So just by adding an observer around it, it will automatically re-render whenever this particular value changes. And the value changes whenever you switch between the pending and completed filters, or when add and remove to-dos, and so on and so forth, right? So the observer automatically tracks all of those things and is able to show it whenever this particular value changes. Now notice that, again, as we saw it in the counter example, there is no subscription, there is no notification, you're not adding any event handler, there is no attaching and detaching of things. It's all happening automatically in the background, just purely by expressing the intent of what you want to be re-rendered, right? And based on what, right? You have an observer, which means it's an indication to Mobx that this is a widget that contains a builder function and that may have an observable that it will be using to render itself. And when any of those observables change, please re-render the builder, right? So it runs the builder function again and re-renders that particular widget. And this in itself is so simple and powerful that you can actually build applications, anywhere from like a counter all the way to a trading desktop, let's say. So that's about the description widget. The to-do list also does something very similar. It has an observer around the list, and then monitors the length of the visible to-dos, right? And then it also has an observer at the item level, because item itself could be changing, right, based on whether you check or uncheck the done flag, or you press the remove button, and so on. So by adding an observer at this level, you're also ensuring that only when this particular item changes, then only that item should be re-rendering, right? You should not be re-rendering the entire list. There's no need to do that, because that's, first of all, a performance cost you have to give. And moreover, it's not really efficient to render the entire thing when only a small part of it has changed, right? So it's actually recommended to sprinkle observers all over the place, and specifically around the items, around the observables that are actually changing. So rather than creating one observer that does, looks at everything around the world, you can create specific observers and assign them only to the parts that are changing. Now the action bar is also, again, very similar. It has an observer around the filter itself, and based on the selection of the filter, it highlights that particular filter on the segmented control. And then you have the add to do, which is just a text field, and it fires off an action anytime you hit enter or when the value changes, and that adds a to do to the list. Right. So in terms of simplicity, you do see that things are easy to follow. I mean, although there is enough of nesting of widgets, but that's purely for styling purposes. But the amount of data that you're reading and where it's being re-rendered, it's kind of obvious to you. In fact, in a Mobx code base, you can always look at the observers and see the parts of the data that are actually being used to render the UI, and that kind of makes it easy to get a sense of how the UI is actually reading the various data parts from the model. I think with these two examples, you get a sense of what you can achieve with Mobx, from the simplest counter to something more complex like to-dos, and also tackling other kinds of examples that you will see in the Mobx examples project. Now, rather than jumping into more examples, I want to take a step back and kind of give you a sense of how to get started with Mobx, and show you the website and the getting started guide, which will help you on the journey to get started with Mobx itself. So let's jump into the website. So if you go to mobx.netlify.app, you will see the website that contains all the documentation and a set of guides and testimonials from people about how Mobx can be used to use in your own Flutter apps. Now, specifically, if you're the first-time user of Mobx, I would suggest getting into the Getting Started section. And this is a section that will give you a step-by-step guide around setting up a Flutter project, and then applying Mobx to it for managing your state. In fact, it also is a example that gives you a more detailed walkthrough for the counter example. And at the end of it, when you go through this whole getting started guide, you should have a counter example working with Mobx. And a lot of these guides that you see over here also talk a little more about the way things work in Mobx, and the way you should be thinking about Mobx in general, and the kind of complexities you can deal with, and how you should break down your stores and things like that. So there's a lot of enough information over here, and some of these articles have been written by the community, so it's not like I'm the one writing all of this. Some of these are actually hard-earned knowledge that people have contributed back to the website. And you can see it inside the core concepts, which talks about some of the abstractions that we mentioned in the presentation, but going into a lot more detail about why and the how of things. And there's also some community section which will which showcases some of the blog posts, videos, and podcasts, and other kinds of stuff that people have built using Mobx. Although this is not an exhaustive list, it kind of gives you a sense of what has been done already in the community. And there's a lot more happening, and I'm open to PRs for people to send me, which will keep adding to this list of things. All right, so that's all about the website. Let's get back to the presentation now and wrap things up a little bit. So in this session, we saw some of the fundamentals of Mobx, the different abstractions that it has, the few examples that kind of showcases how Mobx can be used to create your simple counter example followed by the to-dos, and a lot more examples in the Mobx examples project. And many of these actually have been written as example guides on the website, which you can read for yourself and also get a more detailed walkthrough of all the examples that you have over there. So I would definitely encourage you to try out Mobx. I think it's a fun framework and kind of gets out of the way as quickly as possible, and allowing you to focus more on your business logic and the application logic rather than wiring data and UI and always being in this mode of connecting things together. I think the automatic way of discovering the intent of using an observer with an observable just makes Mobx so easy to use, and takes away all the pain of managing state in general. Well, having one less problem to solve inside your application is always a good thing, right? So Mobx takes care of that for you and lets you focus and gives you time to focus on things which actually matter to you. So hopefully this was a useful session, and please feel free to ping me on a chat or elsewhere and to answer any more questions. And definitely go to the website mobx.netlify.com. There's also a link to the Discord server where there's a lot of community people engagement happening, and many of the folks have enough experience and can tackle a lot of the questions that you may be having over there. So I encourage you to go on the Discord channel, and I look forward to seeing you over there.